the last variable. Finally, let's talk about what happens when we change d. As we can see, d is something that's added or subtracted to the function outside of the function itself. So we have sine of x plus d, where d equals 0 here. So once again, this is our normal sine curve. When we increase the value of d, let's say to 1, sine of x plus 1 just takes the whole function and slides it up 1 unit. As we increase d further and further and further, we increase the height of the function. On the other hand, if we make d negative, then we are lowering the function by d units. We can think of d as the midpoint line of the function. The line going exactly through the middle of it, that's the value of d. So as we saw, d shifts the graph up and down, and the line y equals d is the midline of the sinusoidal graph. So if we ever have a sinusoidal function, and we want to figure out the value of d just by looking at the graph, sometimes it can be a little tricky because we don't know, is the midline here, is it here? A little hard to tell. What we can do is look at the value of the highest point of the graph, the value of the lowest point in the graph, and then take their average. That will be exactly the midline of the graph. That will be d. So the midline of this function, we can see it pretty easily right around here. But if we were ever unsure, we know that the graph is as high as 5 and as low as 1. And the average of those goes right through the middle. This is the midline of d equals 3. In class, we will be sketching the graph of given sinusoidal functions with different values of a, b, c, and d. We will be creating sinusoidal equations from a graph, so I'll give you a graph and we'll figure out what equation describes it. And finally, we will be solving word problems using a variety of sinusoidal functions. Can't wait to see you there.